So they're giving us a drug in a patient's body is modelled with this. K is positive, T is time in hours after initial dose. Write down the amount of the drug when T equals 0. Well, that's easy enough. So A of 0 equals 500 times e to the power negative k times 0, which equals 500, and this becomes 0, and e to the 0 is 1, because anything to the power 0 is 1. 500 times 1 equals 500, so it's 500 milligrams. Part B, after 3 hours, the amount of drug in the patient's body is decreased to 280, so we've got that 500 e to the negative k times 3 equals 280, and that's an equation. So if I plot that as one graph and that as one graph, the intersection point with my value of k, I need to put x instead of k. So I need to do a sketch of that. Looks a bit like this. To try and work out this answer, we'll do a graphs page number 2 and put in the one side equation first, 500 e to the power, this is negative 3x in effect, because it's negative k times 3 and k is the unknown. That's one side equation. The other side equation, do tab to add a new graph, and the other side equation is 280. And I can't see 280, so I need to go up. Let's go up to 300 here to get a bit of a gap. So we can see it. There's my 280, there's the graph. I could make this a bit smaller, let's make it 5. And change this one to -1. Actually, that's enough to see the graph with. And we want to find that intersection point. Intersection points menu, geometry number 8, points and lines number 1, and intersection points number 4. This comes up now and tells me that I need to click on the first and the second graph. First graph, second graph in any order. It's given me the intersection point, and escape out of that because I don't want to add any more points. So the x value is the value where k was, because that's where the k is there. So the x value is that I want, and that's k. Put my hand over that, and then click on the var button and say store the variable. So store that and call that k, because that's what I need for that. Press enter, and then now this is telling me that this is now linked to k, and it's in bold to say it's linked to another variable. So if I go back to, I'll add in a calculator page, add a calculator page, I can now see if I press K, that's the value of K to more detail. And this is y equals 500 e to the negative 3x. And this is y equals 280, and this is 0.19327 comma 280. So we've got k equals 0.19327 which is approximately equal to 0.193. Part C. So the second dose, the midnight drug is, so when it's 140 milligrams, we now know the equation because that was the equation, but we know K. So we have AT equals 500 e to the negative 0.19327 ... T. So now we to find that, to another graph, we need to define when that here is equal to 140. So another graph here. Now we can draw the entire graph, so add a new graph page so it doesn't get confused with the old one. Put in the equation now that we know that it's 500 e to the power, then it's negative k multiplied by, otherwise it thinks a variable k called kx, multiplied by x, because I can't put in t. That's my actual graph. And again, given it starts at 500, let's go up to 600 here to see it. There's my graph. Let's go to 20 just to go a bit further across to see what's happening. Don't need to change this one. I need to go to -1 there. That's changed all the values on the axes. And now when we see this, we want to find out when that is at 240. So, 140. So Let's tab here now, make that 140 the other graph, and this is where it's at 140, so same thing again, menu, geometry, points and lines, intersection points number 4 between this graph and this graph. And it's given the intersection point. That's the value you want for t. If I hover over that value, actually I'm going to control click and then drag it up. Hover over that value, oh no, to come out of the adding value, hover over that value and press the plus button. Each time I press plus, it adds more details there, so I can see it in more detail without having to copy it onto the calculator page. And now we've got this decays like this, and now we want 140 here, so this is y equals 140, and this is y equals 500 e to the negative 0.19317 ... t, and this intersection point here 6.5863 ... 140. So we have that t equals 6.5863, which is approximately to 6.59 to 3 significant figures.